Welcome to CERN Learning. This video is to discuss the answers for the questions which were asked NET June 2021 in Theory of Computation. The first question is, which of the following languages are not regular? Three different languages are given. We have to identify whether these languages are regular or not. Choose the correct answer from the options given below. Before going to identify whether these three languages are regular, let us recall the grammar, the languages and the machines to recognize the strings derived from the grammar, which was discussed in one of my videos. To solve this question, let me give some important points. First one is the regular grammar. Regular language is recognized by the finite state automaton. This finite state automata has no memory elements. This finite state machine will start from the initial state and recognize each symbol, and it would reach the final state. If it reaches the final state, then the string will be accepted. The second one is context-free grammar, which is recognized by a machine push-down automata. This push-down automata has one memory element, which can be called as a stack to recognize the strings. Third one is context-sensitive grammar. It is recognized by the machine called linear bounded automaton, which has two memory elements to recognize the strings. In addition to these points, let me give some more points to solve this particular question. Fourth one is, we need to check the powers of these symbols. If the powers are different, then it is regular language. And the next point is, if the power are same, we need to check whether this language can be recognized with the help of one memory element or two memory element. So with these key points, let us solve this particular question. So take the first language. This language has different powers, 0, 1 whole power n, 0 power k. So the power is different. And if the powers are different, then it is a regular, such that the condition is n is greater than k and k greater than or equal to 0. Since we need one memory element to keep track of this n and k, it is not a regular. It is a context-free grammar. Take the second language, L equal to C power n, B power k, A power n plus k. Here the powers are different, and again we need a one memory element to keep track of this n plus k. So this is not a regular language. Take the third language, 0 power n, 1 power k. So the powers are different, but we need one memory element to check whether n is not equal to k. So this is not a regular language. The answer for this question is A, B and C. These three languages are not a regular language. The second question is, any string of terminals that can be generated by the following context-free grammar, where S is start non-terminal symbol, and the production rules are given. We need to find out among these four options which one is the correct option. To identify the correct option, let us derive the set of all possible strings from this particular grammar. Let us take the production rule S derives xy, where x is the start symbol. In x and y, I can substitute 0, y for 0, then I will be able to get the possible string as 0, 0. And then Second is, instead of x, I am going to replace this x with 0x. So s derives. Instead of x, I am going to substitute 0x, and instead of y, I am going to substitute y0, and then this x and y, I am going to replace this x with 1x. 0, 1, x, y, 0. And for this x, I am going to replace 0, 0, 1, 0. And for this y, I am going to replace y as 0, 0. So I will be able to get 0, 1, 0, 0, 0. That is the next possibility. And then this other possibility is, let me take s derives x, y. Instead of x, y, I am replacing this x by 1x and this y by 1y1. I am replacing this y by y1. So I am getting a string 1, 0, 0, 1, 1, 0, 0, 1, etc. The options listed below. The first option is has at least 1 1. If we analyze the possible string, the third one has 2 1s. So this option is wrong. Second, has no consecutive zeros or ones. So here we have 2 consecutive zeros. So this option is also wrong. The third option is should end with 0. So if we check the first possible string, it is the end of the string is 0. Second possible string also ends with 0. But consider the third one, it ends with 1. So automatically this option is also wrong. Has at least 2 zeros. So if we check all the possible strings, at least 2 zeros are available. So the option 4 is the correct option. Let us move on to the third question. Here 2 different lists are given. We have to match the list 1 with the list 2. To match, we should know what is Green-Patch normal form and then Chomsky normal form and S grammar. So Green-Patch normal form, in which the production rule of the form, the start symbol derives epsilon, or the production rule in which any non-terminal which derives a terminal, or the production rule which has one terminal followed by one or more non-terminal. If the production rule is of the form, then we can say it is a Green-Patch normal form. Chomsky normal form, in which the production rule is of the form, the start symbol which derives one or more non-terminal, and this non-terminal can derive a terminal directly. And S grammar. This S grammar is in which the non-terminal derives a distinct terminals. For example, S derives A S or B double S or C triple S or D. So this dot symbol can derive a distinct terminals, which is called as an S grammar. And then context sensitive grammar is a grammar which has one or more symbols on the left hand side. It is context sensitive grammar. So with this points, let us match the list 1 against list 2. Take the first one, S derives xy, x derives 0, x derives 1. So the production rule is of the form 2 non-terminal. So which matches with the Chomsky normal form. So for the A, the option is 3. And take the second one, B, S derives. Here the start symbol derives distinct terminal symbols. So automatically it is a yes grammar. So the option B is yes grammar, which is 4. So if we match these options with the given options, so let us check this option with the given options. A is 3, B is 4. So A is 3, B 4. Only for this option we have this. So we can select this one. Before selecting this, before confirming this, let us check the third one. S derives AB, A derives 0A, 1A or 0. So B derives 0A. This matches with the grep patch normal form. So C will take the first option, and automatically the fourth one is, if the left hand side contains more than one symbols, then it is a context sensitive grammar. So the fourth one, D, is matches with 2, the option 2. So the correct answer is 3. Let us move on to the fourth question. Given below are two statements. Statement 1 is, the family of context-free languages is closed under homomorphism. The second statement is, the family of context-free languages is closed under reversal. In the light of the above statements, choose the correct answer from the options given below. To identify the correct option, consider the table which is listed. The languages which are closed under this properties are denoted with yes, and if it is not closed under the particular property, it is denoted with no. So here the first statement is, the family of context-free languages closed under the homomorphism. So we will check with the homomorphism of context-free languages. So the context-free languages are yes, it is closed under homomorphism. Take the second statement, the family of context-free languages closed under reversal. So if we check the property of reversal against the context-free language, it is also yes. So this context-free languages are closed under reversal. So the option is both statements are true. Thank you for watching this video.